Good morning, class. Once again, welcome to you all in today's session, in which we are going to deal with the Werner's theory of coordination compound. Along with Werner theory, we are going to deal some of the most important one-mark questions which are being asked there in the CBSE and RBSE board examinations. Okay, the first question, the first topic which we have been going to deal is Werner's theory of coordination compound. It was a theory which was been given by Werner, which do explains about the coordination compound. In this theory, he had explained about two types of valencies possessed by a metal. In this, Werner stated that the metal possesses two types of valency. Number one is primary, which is also known as principal and ionizable valency. Number two is secondary, which is also known as non-ionizable valency. Later on this theory itself, Werner had been explained the difference between primary and secondary valency, and he had also been stated how we are going to calculate them. Okay, so we are going to see the three main postulates of the Werner theory one by one. Okay, so in first postulate, Werner stated that the primary valency of a metal atom is the oxidation number or oxidation state of that particular metal. Say as if I do have an element, do have a compound PtCl4. Here the metal is Pt, and hence if I have to calculate the oxidation number, we will calculate in the same manner what we had did there in redox reaction chapter in class 11. That is, the valency of Pt is to be calculated, so we consider it to be the X. We do have 4 Cl atoms, so we are placing a 4 over here. The oxidation state of Cl is minus ka 1, therefore I am placing the minus 1 over here. The whole complex do not carry any of the charge over it, therefore is equal to, after is equal to, have to place a 0. 4 into minus 1, minus 4. When minus 4 come over here, the value of x comes out to plus ka 4. Therefore, by usage of this procedure, if I am calculating the value of x, that is oxidation state of metal, then this particular oxidation state of metal is said to be what? Primary, principal or ionizable valency. Now comes to the secondary valency. Secondary valency is actually the coordination number of metal. Say as if I do have a complex over here, that is PtNH3 whole 6 Cl4. Here we know that the coordination of metal is being stated by the number of the ligands surrounding the metal. It has not to do anything with this anion. As we do have 6 ligand over here, so the secondary valency of PtCl4 plus comes out to 6. Okay, now second point, primary valency is always satisfied by the negative ion. Meanwhile, the secondary valency is being satisfied either by the negative ion or the neutral ligand, which do carry the lone pair and do have tendency to donate the electron to the metal. Okay, possibly we are being clear with these two terminology, that is oxidation state of metal is said to be what? Primary valency. Coordination number of metal in a complex is being termed as what? Secondary valency. Primary valency is being always calculated with the help of negative ion. That means it is being detected by the negative ion or it is being satisfied by the negative ion. Meanwhile, the secondary valency can be satisfied by negative or neutral ligand. Now, the third point. Primary valency do not have any direction. Meanwhile, the secondary valency is directional in nature. How can we explain this? Guys, we know that the NH3, the nitrogen do carry the lone pair of electron. When this coordination compound is being formed, this nitrogen from this NH3 molecule donates its electron to the metal with the help of this bond, which is known as coordination bond. As we can see that the direction of electron is from ligand to metal, so we can say that it do have directional character. Meanwhile, in ionic compound, we are not able to see any particular direction, so it has been said to what? Non-directional in nature. Okay guys, later on this research which was being taken place by the Werner, he had stated that if we do have any complex, and if we place this complex in an aqueous medium, then this compound cleave itself into ions. That means if this is the compound, that is PtNH6 3 Cl4, PTNH3 whole 6 Cl4. If this compound is being placed in aqueous medium, the bond will cleave from here in this manner. The Cl4 are over here, so it will move over here, and the charge acquired by this whole complex will be 4 plus, and Cl is an anion, so it is being represented by 4 Cl minus. That means if this whole complex, when placed in aqueous medium, it cleaves itself into ions, we are going to get two of the ions. The forward portion, that is along with the coordination pair, the complex is being having the 4 plus ion charge, and we do have 4 Cl minus ion as the ions over there in aqueous medium. So the number of the ions in aqueous medium comes out to what? 4 plus 1. This whole complex will be considered to be 1 only. Okay, therefore the total number of ions in this particular case will be what? 5. Moreover, if I have to calculate the number of ions, how could we came to know that the Cl over here is only 4. For this, Werner has conducted an experiment in which he had taken this coordination compound and is being treated to excess amount of AgNO3 salt. When this reaction takes place, AgNO3 being an ionic compound cleave into plus and minus, and when we know that this is a coordination compound which cleaves into again plus and minus, therefore this Cl4, this Cl minus ion get attracted towards Ag plus, as the value of AgNO3 is more, so we are going to get how many moles of AgCl4, because Cl over here is 4, hence it do have strong tendency to attract the 4 Ag plus ion and results in formation of 4 AgCl salt, where when this AgCl salt is being formed, we are able to see the white PPT, and this 4 moles of AgCl indicates that outside the coordination pair, the number of Cl minus ion will be what? 4. Hence, with this, we came to an end of the Werner theory. Now, as per our promise, we are going to deal some of the most important 1 mark questions from this chapter, which we have not been dealt till now. The first question which is frequently asked in the paper is, what do you mean by the mixed complex? If someone says the mixed complex, it means that in this coordination pair, along with metal, more than 2 different types of ligand will be there. Say as if one of the ligand over here is Cl, chloride, and and the other ligand over here is NH3, that is ammonia. If more than one different type of ligand is available in this coordination pair, then this complex is said to be what? The mixed complex. That is, it is mixed from different types of, it is a complex which is a mixture of different types of ligands. Okay, now in the second half, we are going to deal with the 2 terminology, that is inner orbital complex and outer orbital complex. When we know that octahedral do exist in 2 type of hybridization, that is D2sp3 and sp3d2. In case of D2sp3, that is when sp3, if D2 orbital is inner to that of sp3, then these are being termed as D2sp3. In this condition, this complex is being formed by filling of the electrons in inner n-1d orbital. Meanwhile, when D2 lies outside that of sp3, that is, the complex is being formed by outer nd orbital, then this complex is said to what? Outer orbital complex. Okay, probably I feel that this 1 mark question is also very much clear to you all. Now we are going to deal with the second and third important terminology, that is synergic effect or the back bonding. Again, synergic effect does not state anything about the complex, but back bonding explains a lot. Back bonding, that is again bonding. Okay, then what does the back bonding actually refers? We are going to see with the help of this particular structure. Guys, we came to know that the ligand is a species which do have tendency to donate its electron to metal. As a ligand can be an anion or a neutral ligand, it means it do have lone pair along with this. When ligand donates its electron to metal, it do results in the formation of a sigma bond over here. But we know that the metals are electropositive species and it do have tendency to donate its electron. So it do donate its electron to ligand back and results in formation of pi bond. As again the bond is being formed, that is back bonding, again the bond is being formed, therefore this pi bond is also known as back bonding. That is, metal again forms its bond along with ligand. So it is being termed as back bonding, which is also known as synergic effect. Guys, with this we came to an end of the important one mark question. In this particular chapter, we are being left with what? IUPAC nomenclature of coordination compound, a very very important portion which we have been discussing in the later half in the next class. So be with me and we can make this chapter the easiest as we can. Okay guys, till then, bye bye.